In January of 2000, the Conference Board did a survey of households in the United States and found consumer confidence at record highs. In particular, if you ask people, are jobs easy to get? About 60% of the people surveyed gave a resounding yes. The labor market is tight, and workers, everywhere they go, are seeing these signs. If you want a job nowadays, it's pretty easy to get one. In fact, companies are so eager to get good help that they are bidding workers away from their rivals, and there's upward pressure on wages, which is leading the Federal Reserve to be concerned that inflation may be about to break out again. Now, I've heard of some cases in which companies pay their employees bonuses by bringing other people to work for them, and that new employees may actually get a car as part of the deal. Workers have it really good, and those of you who are going to be graduating from college in the spring of 2000 can look forward to a lot of opportunities. Now, contrast the situation of college students in 2000 to the situation of college students in 1991. Students who graduated in May of 1991 may have had to wait several months to get a job. Jobs were hard to get, and instead of help wanted signs, we had students and other people walking around with job wanted signs. They were handing out their resume, knocking on doors, and looking for opportunities. The market was very, very slack. That is, people had trouble finding good jobs and jobs that paid wages that they were expecting. People had more trouble making ends meet, and there were other people who were simply unemployed and dropped out of the labor force because they were discouraged. Now, what numbers would we look at to gauge the status of the labor market? That is, what statistics tell us whether the labor market is tight or slack? The Bureau of Labor Statistics publishes an unemployment rate every month. And what we're going to do now is look at how that unemployment rate is calculated so that next time you hear it mentioned on the radio or see it in the paper, you'll know the story behind it. The unemployment rate is based on a survey conducted each month by the Bureau of Labor Statistics. The Bureau of Labor Statistics surveys about 60,000 households each month and asks two questions. How many people in your household are employed? And how many people have been looking for work in the last month? The population of the survey is all of the adult, non-institutionalized population of the U.S. That is, all of the people 16 years of age or older who are not in prison, in the military, or in some other institution. By the way, an institution of higher learning counts as an institution, so if you're a college student, you are, from the point of view of the BLS, institutionalized. Here's our population. The labor force is calculated as the sum of two smaller groups. First are all of the people who answer yes to the question, do you have a job? That is, the employed. And next, the people who are actively looking for work but haven't yet found a job, that is, the unemployed. If we add the total number of people that are employed to those who are looking for work but not yet employed, we get the labor force, and that number is 137,673,000, and these data are from 1998. Now, once you've got the labor force calculated, you are able then to calculate the unemployment rate. The unemployment rate is going to be those people who are unemployed as a percentage of the total number of people who are in the labor force. That is, the unemployment rate doesn't include all the people who are potential workers, that is, this population up here, but only those who are actively choosing to work or are trying to get a job because they're looking for work. Let's do a calculation now to get this. The unemployment rate itself will be calculated as the number of people who are unemployed, 6,210,000, divided by the total labor force, which is 137,673,000. And if we take that fraction and multiply it by 100, we get the unemployment rate, which in this case will be equal to 4.5%. So the unemployment rate is the number of workers who are looking for work and not finding it as a fraction of the total labor force. The next thing we can calculate is the labor force participation rate. That is, how many people are in the labor force of the total potential population that could work. So to calculate that, take the number of people in the labor force, which is 137,673,000, divide that by the adult population that's not in institutions, multiply by 100, and you get a labor force participation rate of 66.5%, or about 2/3 of the people who could work are either working or are looking for work. So that's how to interpret these numbers. When you hear the labor force participation rate is rising, that's because people are being drawn into the labor market, perhaps by the prospect of higher wages. When you hear that the labor force participation rate is declining, it may be because people are discouraged and are dropping out and no longer looking for work. When you hear the unemployment rate is low, that tells you that of all the people who would like a job, only a very small fraction is unable to find one right now, probably because firms are so eagerly looking for help, and therefore getting a job is easier. Now, whenever we know these numbers, we can then think about them critically and ask, is this really telling us the whole story about the way the labor market works? There are three things to know about the Bureau of Labor Statistics measure of the unemployment rate. The first problem is that it treats part-time workers exactly the same as full-time workers. So there may be people who would like to work full-time but only have part-time jobs, what an economist would call an underemployed person. Underemployed people don't show up in these numbers because if you answer the question, have you had a job this month, the answer is yes. You don't have to have worked full-time to answer the question yes. Therefore, the numbers don't distinguish between full-time and part-time employment. The second qualification is that there are discouraged workers, workers who've dropped out of the labor force and therefore don't count in the unemployment rate. The unemployment rate could actually be falling with the labor force participation rate falling at the same time, and we have a problem in the economy. That is, people are not looking for work. They've stopped looking because they're discouraged, and therefore that fraction of the population that's in the labor market is shrinking. But if the people who are looking for work are finding jobs, the unemployment rate will not be rising. It could actually be falling, even though fewer people are working. So the discouraged worker effect is ignored by the unemployment rate. The third problem is that research has found that most spells of unemployment are short, that is, people moving between jobs. Someone who loses a job or leaves a job and finds another one relatively quickly. We would like to have some measures that distinguish between longer spells of unemployment, which point to more intractable problems. People who'd like to have a job but after several months have still been unable to find one, as compared to people who are only out of work for a couple of weeks. So the unemployment rate does not tell us the fraction of workers who are unemployed who have been so for several years, and therefore are part of a more serious problem than those people who are only between in a short stay between jobs. Now let's look then at how the numbers work one more time to remind ourselves about the calculation. Whenever the Bureau of Labor Statistics does its calculating, it looks first of all at the overall adult population in the United States, 16 years and older, not in an institution. And it divides all of those 207 million people into three categories: those who are presently employed, those who are looking for work but presently unemployed, and those who are not in the labor force. If you're not in the labor force, we take this red chunk out of our circle, and the blue and yellow that are left constitute the labor force. Some of its members are working, others are unemployed. If you divide the yellow area by the sum of the yellow and the blue area, you get the unemployment rate. It is the fraction of those unemployed divided by the fraction of those people who are in the labor force in total. So if you look at all of the adults in the United States, 63% are employed, 3% are unemployed, and 34% are not in the labor force. Divide 3 by the sum of 63 and 3, so 3 divided by 66 gives you 4.5%, the unemployment rate. We'll be thinking a lot about what unemployment means to our economy and how it's correlated with the business cycle. But now you know what the vocabulary is, so when we have these discussions, you'll know the pictures behind the words. When I was a kid, my grandmother would take me for a hot dog at Harry's Hot Dogs. The hot dogs cost 5 cents a piece, and I could usually eat 2. When we didn't eat hot dogs, we'd go across town to Joanne's Burgers. Joanne sold her burgers for 10 cents a piece. I could usually only eat one of those. Nowadays, I still eat burgers and I still eat hot dogs, and I still go to Harry's and Joanne's. Everything's the same. Same burger, same hot dog, but the prices have changed. Harry's hot dogs now sell for $2 a piece, and Joanne sells her burgers for $4 a piece. So what's going on? What's changed? The quality of the products is unchanged. Even more remarkably, it still costs the equivalent of 2 hot dogs to buy 1 hamburger. There's been no change in the relative prices of the 2 products. Prices have nonetheless increased substantially since I was a kid. What gives? The answer is, the change in prices is not about the value of the products, and certainly not about the relative value of hot dogs and hamburgers. It's about the relationship between products and money. When there is a general increase in the level of prices in an economy, we say that that economy is experiencing inflation. And inflation means that in general, it takes more of this to get one of these than before. That is, inflation is a general increase in all prices across the economy. Let's talk about inflation, what causes it, and why you should care about it. This first discussion is going to focus on definitions. First, inflation. Inflation is a general increase in the price level across an economy. Deflation, by contrast, is a general decrease in prices across an economy. Deflation is much rarer, but nonetheless happens from time to time. Hyperinflation is a very rapid increase in prices, in fact so rapid as to be remarkable. People's response to hyperinflations is very dramatic. And finally, stagflation. Stagflation is a period in which prices are increasing at the same time as output, or real GDP, is actually stagnant or decreasing. Stagflation is also rare and requires some explanation. We'll get to those explanations after we've talked a little bit about the history of prices in the United States. And those explanations are going to take us deeper into the modeling of macroeconomics. What is the relationship between money, prices, and output in the economy? But first, let's talk about inflation. In the United States, over the last 25 years, the general rate of inflation has been about 6%. That's been the average. The United States is not unusual. Most of the industrialized countries of the world experience a low inflation rate most of the time. That is, prices are generally increasing. Some periods in the United States have been well outside of this average. For example, in 1980, the inflation rate was between 13 and 14% on an annual basis. That was, prices were rising relatively rapidly for U.S. experience. Recently in the United States, since the mid-1990s into the year 2000, the rate of inflation has been below 3%. These are very, very low inflation rates for the United States, and we haven't seen prices rising this slowly since the 1960s. In general, though, there is some rate of inflation in most countries most of the time. Deflation is much rarer. Deflation occurs typically during periods of economic stagnation or depression. In the 1890s, when the United States was in a deep recession, which was actually a depression, the price level fell during that decade by about 23%. In the 1930s, during the Great Depression, the GDP deflator fell by about 14% during the course of several years. In Japan, in recent years, that is in the early 1990s, there was a period of deflation that the Japanese called price destruction. That is, prices were falling, and because prices were falling, consumers began to change their behavior. When you see prices falling, you reason to yourself, well, this computer will cost less next week than it costs today, so I'll wait to buy it. And when everyone waits to buy, stores can't move their merchandise, and therefore they lower prices further. When prices begin to fall faster, people wait longer to buy things, looking for bargains. And therefore the economy can stagnate. With stores unable to sell products, factories stop producing them, then people are laid off of their work, they can't afford to buy products, and there's even less stuff bought and sold. Now, you might have experienced the same thing in the computer industry. That is, you see how rapidly computer prices are falling with the advance of technology, and you keep saying to yourself, why should I buy a computer this week? If I wait till next week or 6 months from now or next year, I'll get a better computer at a lower price. And therefore, you never get around to buying a computer at all. Well, that's the way things work in an economy that's characterized by deflation. Falling prices can cause great problems for an economy. Hyperinflation is a very weird animal, and when it occurs, it usually makes the headlines. The Wall Street Journal reported in Bolivia in 1985 that there was an inflation rate at about 38,000% over the course of 6 months. Look at this. In January of 1985, you paid $1 for a loaf of bread. Well, in June of that same year, you were paying $38,000 to buy the same loaf of bread. No change in the product. It wasn't suddenly super bread. It was the same product. And yet you're paying all this extra money because the prices are rising so rapidly. Why did that happen? Well, it happened to a large extent because the government was just printing a lot of money to pay its bills. And this economy was awash in trash cash, money that really had no value. It was just paper. And because the money was so plentiful and so cheap, merchants required bucket loads of it for you to buy anything. During a period of hyperinflation, you can sit down in a restaurant, order from a menu, and before the waiter brings your food, the price of your meal may have doubled or tripled. Now, what do people do when they're in a hyperinflationary economy like this? They become very suspicious of money. They are unwilling to accept money in exchange for goods and services, and frequently the economy will revert to barter. During some periods of hyperinflation, say in Germany after the World Wars, nobody would accept these wheelbarrows full of worthless German marks in exchange for anything. People instead bartered, trading the overalls they had produced at the factory and insisted on being paid by their boss for chickens that they went home then and slaughtered themselves. The economy moves away from the efficient kind of transaction that we get when everything can be paid for with cash towards the more primitive and costly form of exchanges that barter implies. So hyperinflation usually causes people to be afraid to accept money, afraid that it's losing its purchasing power too rapidly, and therefore they revert to barter, which implies all kinds of costs for the economy. Other instances of hyperinflation. In Serbia in 1993, the inflation rate was 10% a day, which over a period of time compounds into an astronomical rate of increase in prices. Also, in the Ukraine in 1993, after the collapse of the Soviet Union, the inflation rate for the year was 4,735%. When prices are rising that rapidly, everyone becomes very, very concerned about money losing its value, and therefore people are afraid to accept it. Finally, stagflation. Stagflation is this weird combination of rising prices and declining output. In the United States, two remarkable examples of stagflation coincided with increases in the price of oil. In the early 1970s, in 1974, real gross domestic product growth actually was negative. That is, output fell by about 0.6%, at the same time that prices were rising at an annual rate of 11%. This was in large measure due to the oil price supply shock. Prices going up, and at the same time, because the cost of doing business was rising, companies produced less. In 1980, real gross domestic product growth was negative 0.3% in the same year that inflation was about 13.5%. Same story. An oil price shock affected the economy, reducing output at the same time that it increased prices. So this is what we mean when we talk about inflation, deflation, hyperinflation, and stagflation. We'll consider now how inflation actually affects your prospects in the market and your behavior. You can buy less with a given amount. A given amount of money will buy a small number of hot dogs. But when hot dogs are inexpensive, that is, the price is low, your given hot dog allowance will purchase a lot more satisfaction. There is a relationship between prices and purchasing power that is a reciprocal relationship, and that's the relationship that we're going to be studying in this lesson. When prices are going from low prices to high prices, that is, when there is inflation in the economy, the value of the dollar is shrinking. That is, your purchasing power is going from being able to buy a lot to being able to buy a little. In this lesson, I'm going to begin by giving a simple numerical example, and then we'll talk about how you can use the GDP deflator to show the relationship between the inflation rate and purchasing power. Let's start by assuming that we are in a period of inflation, and let's let hot dogs be a representative good. That is, the price of all goods and services across the economy is increasing at some general rate, and we're going to look at the price of hot dogs in order to infer what's happening to purchasing power as prices are rising. We're going to be focusing now on the reciprocal relationship between the price level and the purchasing power of a dollar. That is, what will a dollar buy as the price level is changing? And I've written out here as clearly as I can the formula that shows this reciprocal relationship. That is, 1 over the price level equals the purchasing power of a dollar. Let me make this very clear. Let's suppose that the price of a hot dog is 5 cents. Well, what's the purchasing power of your dollar? 5 cents is the same thing as 1/20th of a dollar. Therefore, the reciprocal of 1/20th is 20. Your dollar will buy 20 hot dogs. That's its purchasing power. Now suppose we're in a period of inflation so that prices are rising and the price of a hot dog goes up to $2. What's happened to your purchasing power? Well, your dollar will no longer buy even a whole hot dog. $2, or 2, has a reciprocal of 1/2. That is, you can now only afford half a hot dog. Your purchasing power has shrunk from 20 hot dogs at a price of 5 cents apiece to 1/2 a hot dog whenever the price is $2 per hot dog. This simple example makes clear that the price level and the purchasing power of the dollar are reciprocals. Now, let's look at some examples using the GDP deflator. Suppose that we're in 1996, which is our base year for calculating the GDP deflator, and we calculate the price of a market basket of goods and services. That is a little bit of housing, a little bit of transportation, a little bit of medical care, a little bit of clothing, etc. And we're going to call the price level in 1996 100 because it's our base year. We look at those prices again in 1999, and we find that the price of the goods and services as a ratio of the same prices in 1996 is equal to 104. That is, prices have increased by about 4% between 1996 and 1999. So if we write the GDP deflator not in the form that we usually write it, that is multiplied by 100 to get 104, but let's write it now as in hundredths, 1.04, to show the 4% increase in prices between 1996 and 1999. Well, what's happened to the purchasing power of a dollar between 1996 and 1999? That is, how much can we afford to buy in 1999 with a dollar if we measure it in the prices of 1996? Prices are higher in 1999, therefore the dollar won't buy as much. Well, if you take the reciprocal of the GDP deflator, 1.04, you get 0.96. What's that saying? It's saying that what you could have bought for 96 cents back in 1996, now it costs you $1 to buy in 1999. That is, $1 in 1999 is only worth what 96 cents was worth back in 1996. You can afford to buy less. Your purchasing power has shrunk by about 4%. Your purchasing power shrinks at the same rate that the price level increases, because the price level and your purchasing power are reciprocals of each other. Well, let's take another example during a period of deflation. If we look at the years between 1929 and 1933, we'll see falling prices. If we choose 1929 as the base year, and we call the price level in that year 100, or 1.00, if we look at prices in 1933 during the Great Depression, we see that the price level has fallen by about 24%. That is, we've gone from 1.00 down to 0.76. So we now have lower prices in 1933 than we had in 1929. Now, what does that mean? What's going to happen to the purchasing power of your dollar when prices are lower? It's clearly going to increase. You're going to go from a small purchasing power to a bigger purchasing power. And if you take the reciprocal of 76%, you get 1.32. That is, the purchasing power of the dollar has increased by about 32% in this example. Now, the reason the numbers don't add up exactly, the reason I can't say a 24% decrease in prices is equal to a 24% increase in purchasing power, is because once your percentages start getting large, you run into this problem that a 50% increase is, or sorry, a 100% increase is the reciprocal of a 50% decrease. You wind up with this problem that we've discussed earlier about the calculation of percentage changes. But you can still use this formula anytime. It always works. 1 over the price level gives you the purchasing power of the dollar. And when the price level is only 76% what it was before, your purchasing power is going to be 132% of what it was before. Falling prices give us an increase in the purchasing power of the dollar. So, in some cases, whenever prices are changing very rapidly, people may become afraid to use money. We've discussed that in periods of hyperinflation, people are afraid of rapid changes in the purchasing power of money and therefore just won't accept it and revert to barter instead. But typically, people are looking at the rate of inflation to make decisions about how to behave in an inflationary environment. When prices are rising rapidly, people are less inclined to save money because they're afraid that the interest they earn won't compensate them for the loss in purchasing power. Therefore, they spend more today. And in spending more, they may actually exacerbate the inflation. But we'll get to that later. Also, when prices are falling, people are less inclined to buy things today and more inclined to save because the falling prices are an extra return for their delaying their consumption. So, the point of this discussion is that the price level is the reciprocal of the purchasing power of money. That is, when prices are going up, you're going to find that the purchasing power of the dollar is shrinking. And this simple formula allows you to calculate that relationship. We've said a lot about inflation, what it is and what causes it, and by now you're wondering, well, who cares? Why should I care that prices are rising rapidly in the economy? Especially since my paycheck tends to rise at about the same percentage rate as the price of the goods and services that I buy. Does it really matter? The answer is yes, it does. There are several costs to rising prices in the economy. First, let's talk about how inflation redistributes wealth. Whenever the inflation rate rises, whenever prices are increasing at an unexpectedly rapid rate, people who lent you money at 10% interest, say, are suddenly finding themselves getting back in repayment less purchasing power than they originally lent you. I lent you money at 10% interest because I expected the inflation rate to be 5%. If the inflation rate actually turns out to be 15% instead of 5%, that 10% interest that you pay me doesn't compensate me for my loss of purchasing power. As a lender, I'm worse off when there's unexpectedly high inflation. On the other hand, you as a borrower are better off when there's unexpectedly high inflation, because it's easier to earn money. Your paycheck is probably higher, and the goods and services that you're giving up in order to repay your loan are less. You're giving up less because money is cheaper. So when there's unexpectedly high inflation rates, income or wealth is redistributed away from lenders and in the direction of borrowers. Lenders hate unanticipated inflation because it shrinks the purchasing power of the money they get repaid. Borrowers like it because it makes it less painful for them to repay loans. A second kind of redistribution is away from people who live on fixed incomes. People who are on fixed incomes that don't rise at the rate of inflation find the purchasing power of their fixed incomes shrinking. Some people who live on fixed incomes are living on the interest on bonds that they hold. Well, they're lenders, right? Like the story I just told. So the money they're getting has less purchasing power than they expected because prices rose unexpectedly rapidly. Other people who live on fixed incomes are pensioners or other people who have annuities of some kind. And all in all, you can think about people living on fixed incomes as lenders or else as recipients of government transfer payments. People who live on Social Security or other kinds of public assistance are often on fixed incomes. However, in recent years, more and more public assistance programs are indexed for inflation. So as we've said before, Social Security payments rise with the Consumer Price Index so that there's less pain for people who are living on Social Security payments because Social Security payments aren't anymore strictly fixed. They rise with the inflation rate. But anyone who is living on a fixed income, whether they're living on the income from bonds they bought a long time ago or their retirement account from their company, which was a form of loan that they made to their company, which is being repaid to them in retirement, their fixed incomes are going to shrink in purchasing power when prices rise. One more thing that inflation does, inflation provides an occasion for the government to impose an extra tax on its citizens. By printing extra money, the government can take the cash that it prints and go buy stuff, roads, bridges, missiles, schools, and the cost of those goods is passed on to customers or to taxpayers in a kind of broad inflation tax. Notice, the government isn't taxing you directly to get money to buy these things. The government is printing the money, so at first it seems painless. But when the government goes out and starts competing in markets, spending its stuff, directing labor into the construction of roads and bridges, it's driving up the price of raw materials and labor for everybody else. So the inflation becomes a kind of tax. It's a way that the public at large pays for government spending when the government finances the spending by printing more money. Now, what are the other costs to the economy? Redistribution isn't really a cost. Redistribution is just taking something out of your pocket and putting it into mine. But there are ways in which inflation shrinks the overall amount of wealth created. There are ways in which inflation makes the total pie smaller. Let's make a list of those factors. First, inflation involves what we call menu costs. That is, whenever I go to a restaurant and I look at a menu, I see what there is to buy and how much I have to pay for each item. So if there's inflation, that means that this restaurant is going to have to print its menu more often. Or it's going to have to put it on a computer or a television screen or something so it can update its prices more frequently. Whenever people have to get information about prices in order to make decisions, and when prices are changing rapidly in an inflationary environment, there are menu costs, which are a kind of transaction or information cost, the cost of communicating the changing prices to individuals in the market. So stores have to go through with their pricing gun and put new tags on all the things that are on the shelves, and they have to print new menus, and newspapers have to come out with daily updates of prices, and all of this is costly. The next kind of cost is the cost of unproductive activity that people undertake in order to protect themselves from inflation, so-called shoe leather costs. In an inflationary environment, the last thing you want to do is carry a bunch of cash around in your pocket, because if you've got money in your pocket, the value of it is rotting even as it's sitting in your pocket, because prices are going up and its purchasing power is shrinking. Therefore, what you'll tend to do is leave your money in the bank longer, earn more interest on it, which at least helps you keep up partly with the cost of inflation, and just go to the bank more often to withdraw cash, which means you're wasting time that you could spend taking care of your children or hooking rugs or programming your computer, and you're wearing out your tires and your shoe leather. The extra time and resources that are burned up while people undertake unproductive activities to defend themselves from the effects of inflation, we can call those shoe leather costs or unproductive defensive expenditures. A third cost of inflation is the misallocation of resources. People are confused about whether prices are rising generally or about whether relative prices are changing. I go to the store and I notice the price of milk has gone up, and I don't know whether that's because of inflation or whether it's because of some kind of disease that wiped out a big chunk of the dairy herd. I don't know. I don't know whether I should buy more milk now because the price of it's about to go up further in an inflationary environment, or whether I should substitute away from milk and go buy orange juice instead because milk has become more costly relative to other products. Consumers and businesses are confused about what to do in an inflationary environment. And remember, if inflation is variable, which it typically is whenever it's at a high rate, when the inflation rate is unpredictable, then borrowers and lenders find themselves in a weird situation. I'm lending you money, and I'm going to charge you an extra high interest rate to protect myself from the possibility that an unexpectedly high inflation rate is going to shrink the purchasing power of this loan before you repay it. So that's a kind of defensive action that lenders are afraid to make loans except at very, very high protective insurance rates. So these interest rates that lenders charge, the decision about whether to buy milk or not, perhaps I put my money into real estate or art or something that rises with the price level rather than lending it to a business that might use it for capital and making a profit. All of these are distortions of resource allocation that result when inflation confuses people. People don't know whether relative prices are changing or whether the general price level is changing, and therefore they don't know what to do. Do they save money? Do they invest in this? Do they invest in that? So with inflation, we get risk for lenders, we get higher interest rates to try to cover the cost of inflation, and we get the difficulty that all investors have in trying to figure out whether they can earn a return that's going to be worth giving up purchasing power today. All in all, inflation is costly for the economy, not just because it redistributes wealth from one group to another. Economists aren't quite as concerned about that, but because it causes menu costs, shoe leather costs, and confusion about whether relative prices are changing or general prices are changing. And that leads to a misallocation of resources and inefficiency. You want to know where interest rates are headed. You're concerned about whether now is a good time to start a business. Perhaps you're wondering what the economy is going to be like when you graduate from college. Well, short of a crystal ball, your best source for information about where the economy is headed is published by the Conference Board. The Conference Board is a non-profit group of research and business enthusiasts who collect information and make it available to financial markets, people running businesses, the government, and others who are interested in knowing where the economy is headed. The most famous indicator published by the Conference Board is the Index of Leading Economic Indicators. This index is a single number that averages together information from all corners of the economy to point as to whether the economy is likely to continue to boom or perhaps to slip into a recession. It's a weighted average of information about expectations and behavior across the economy. And it functions sort of as an early warning. That is, when a storm is coming, often you'll notice that animals are anxious or nervous, and their behavior gives you a signal about what the weather is going to be like in a couple of hours. In the same way, the Index of Leading Economic Indicators tells you where the economy is likely to be headed 6 to 9 months from now. The difference between the weather and the economy is that the economy is actually made up by the decisions and choices of the people who are part of it. So to find out where the economy is headed, the Conference Board tries to figure out what people are thinking and doing right now that's likely to influence what the economy will be doing in terms of employment, output, interest rates, and prices 6 months from now. So let's look then at where in the economy we're most likely to get reliable data about what's coming up in the months ahead. That is, which kinds of behaviors and actions and expectations are most likely to have predictive power. The index of leading economic indicators averages together information from manufacturers, from employers, from financial markets, from consumers in the construction industry. And there are 10 components that are averaged together to wind up with the final number that's actually published. This number, by the way, is published every month. Here is a list, then, of the 10 factors that make up the index of leading economic indicators. The first is the average weekly hours worked in manufacturing. When that number is increasing, it could be because labor demand is especially strong, and factories are working their workers longer hours to meet increased demand. When that number is bigger, it's likely that the economy will continue to expand. The second thing is the average weekly initial claims for unemployment insurance. When that number is rising, it could be because people have lost their jobs, are having trouble finding another one, and that could be a signal that a recession is coming. The third component is manufacturers' new orders for consumer goods and materials. Whenever businesses feel like they can sell more goods and services, they're going to be ordering them to put them on the shelves or put them in inventory. Whenever those orders slow down, that could be a signal that a recession is coming. The fourth component is vendor performance. How long does it actually take for you to get delivery of these goods that you've ordered? Whenever it takes longer, that's usually because there's very strong demand and businesses are having trouble keeping things in stock. That's usually a good sign for continued growth of the economy. The fifth component is manufacturers' new orders for capital goods. Are factories installing new tools, new equipment? If they are, it's because they're planning to increase production, and that usually presages continued expansion of the economy. The sixth component is new building permits. Are companies building new office space, new factories? If they are, that's a sign that the expansion will continue. The seventh component is the stock prices. That is what's happening in financial markets right now. Is the prospect of companies strong in the minds of investors? If so, they're going to be bidding up stock prices. The eighth component is the money supply itself. Is the Federal Reserve increasing the money supply, making credit easier to get so that businesses can borrow and expand their operations? Or is the money supply getting tight, perhaps signaling that interest rates are going to go up and slowing down the expansion of business activity? The ninth component is the interest rate spread between long-term securities and short-term securities. When short-term securities have higher interest rates, it's usually because the Fed is tightening short-term credit, and that usually will lead to credit crunches and a slowdown in the economy down the road. The 10th component of the index is the index of consumer expectations. That is a survey among consumers about what they think the prospects are for jobs, higher wages, and a good standard of living a few months from now. When consumers are confident, it usually means that the economy is headed towards more output, more jobs, and growth. So what happens then when we take these numbers, average them together, and get that index? Well, the index typically will peak and turn downwards about 6 to 9 months before employment and output in the economy peak and turn downwards. That is, the index is a predictor of when the recession is coming. The last time that the index showed a protracted downturn was in 1990. By December of 1990, the index of leading economic indicators had shown 5 consecutive months of decline. And sure enough, the following year, a recession hit the economy hard. Now, the economy has been booming throughout the 1990s, but here, in February of the year 2000, the index of leading economic indicators has shown the first downturn in many, many months. So the question is, does this mean that we're about to head into a recession? Is the longest boom in U.S. economic history about to end, or is this just 1 month's aberration? You know the answer because you're in the future. But sitting here, we can only wonder as to whether these economic indicators are still going to have the predictive power they've always had, meaning that bad news may be ahead for our economy, or whether they're just off 1 month. No crystal ball is perfect, but the index of leading economic indicators has a venerable record and is relied upon by people in finance, government, and economic planning to give them insight into what's ahead. Now, here's a mystery. On page 1 of the Wall Street Journal, the inflation rate is reported at 2.5%. And on page 14 of the same day's journal, it says we've had 0% inflation for the last year. Now, how can both of these numbers be correct? Is there an error, or is there something I'm missing? Hold on. On page 1, it says that the 2.5% inflation rate is based on the GDP deflator, whereas on page 14, it says that the 0% inflation rate is based on the consumer price index. Now, I know that these two indexes are different, and maybe that accounts for the difference in their measures of inflation. After all, the Consumer Price Index measures only the prices of a subset of goods, goods that are purchased regularly by households, things like food and clothing, whereas the GDP deflator includes all of the goods and services produced in the economy. So, since the Consumer Price Index is based on the prices of fewer goods, maybe that's why the number is different than the inflation rate measured by the GDP deflator. However, it turns out that there's something else going on. What's going on is that even if the GDP deflator and the Consumer Price Index were based on exactly the same set of goods, you could get different numbers because of differences in the way in which the two indexes are calculated. I think I can make this point very clear with a simple example. Consider an economy that produces only two goods, food and clothing. We're choosing food and clothing because these are goods that consumers purchase. So the Consumer Price Index is based on the price of these goods. And since these are the only goods produced in the economy, the GDP deflator depends also only on the price of these two goods. Now let's look at the gross domestic product data for 2 consecutive years, the year 2000 and the year 2001. In the year 2000, 10 units of food are produced, and the price per unit is $10 for food. So $10 times 10 units is $100 worth of food production. Clothing, $20 per unit, times 10 units is $200 from clothing production. $200 plus $100 gives us a gross domestic product of $300 in the year 2000. Now, as we move to the year 2001, notice that two things have changed. First, the prices of goods have changed. Food is now selling for $20 a unit, and clothing for $35 a unit. The next thing that's changed is that quantities have changed. There's more food produced and more clothing produced. So the gross domestic product is going to be larger because prices are bigger and quantities are bigger. Let's go ahead and calculate the gross domestic product for the year 2001. $20 per unit of food times 15 units of food gives us a GDP from food of $300. Over here, under clothing, we've got $35 a unit times 15 units for $525 worth of clothing produced. 525 plus 300 gives us a gross domestic product for the year 2001 of $825. Now, I'm interested in what's happening to prices between the year 2000 and the year 2001. Now, since there are two different goods being produced, our overall measure of prices has got to be some kind of weighted average of the change in prices. And the way in which that weighted average is calculated is what distinguishes the Consumer Price Index from the GDP deflator. Let's look first at the method used in calculating the Consumer Price Index. The intuition behind the Consumer Price Index is how much would you have to pay to get the same goods you got last year at this year's prices. So we're using the quantities from last year, but the prices from this year. Let's look then at how the Consumer Price Index is calculated. The question is, what would it cost you to buy last year's goods at this year's prices? So let's look first then at that amount of money that you'd have to spend. What I'm going to do is take the quantities from the year 2000 and move them forward to the year 2001 and calculate the spending I would have to do at 2001 prices in order to buy the year 2000 quantities. So in the year 2001, food is now $20 a unit. $20 a unit times the original 10 units of food that we were buying last year is $200 you're going to have to spend to get the same food that you were buying last year. What about clothing? Last year, you had 10 units of clothing. So this year, when you have to pay $35 a unit for clothing, you're going to have to spend $350 to get the same amount of clothing that you had last year. So $350 on clothing, $200 on food gives us a grand total of $550 that you have to spend in the year 2001 when prices are higher to get the same goods that you were buying back in the year 2000. Now, let's calculate the Consumer Price Index. The Consumer Price Index is a ratio. It's a ratio of the amount of money that you'd have to spend this year to get that basket relative to how much you have to spend in the base year, the year whose quantities you're considering. So let's calculate 550, the amount we have to spend in the year 2001, divided by 300, the amount we had to spend in our base year, the year 2000. Multiply that by 100, and you get the Consumer Price Index, which in this case is 183. So the Consumer Price Index for the year 2001 is 183. That's the amount that you would, the amount by which prices have increased from one year to the next. But we're interested in a percentage increase, the amount by which prices have increased in percentage terms, because that's the inflation rate. So what we do to calculate the inflation rate using this method is we take the Consumer Price Index for the year 2001, and we subtract from it the Consumer Price Index from the year 2000. Now, the year 2000 is our base year, remember, where it cost $300 to buy that basket of goods and services. So divide 300, which is the amount you have to spend in the year 2000, by 300, which is the amount you have to spend in the base year, and you get 100. The CPI for the base year, by definition, is always 100%. It's equal to itself. So subtract 100 from 183. So this is the CPI for the year 2001 minus the CPI for the year 2000, the base year, and divide by the base year amount, which is 100, and that's going to give us the rate of inflation. 183 minus 100 is 83, divided by 100 is equal to 83%. The rate of inflation measured according to the method of the CPI is 83%. The CPI has increased by 83% from the year 2000 to the year 2001. The price of that market basket of goods and services has gone up by 83%. That's the inflation rate measured with this method. Now, let's look at the other method for calculating the inflation rate. This one is based on the GDP deflator. Remember, the GDP deflator is the ratio between the nominal GDP in a particular year and the real GDP for that same year. The way you calculate the real GDP, you remember, is to find the value of the goods and services produced in a particular year using the market prices from the base year. So the nominal GDP for the year 2001 is 550, but the real GDP is calculated using the year 2000 prices. So let's go ahead and put the year 2000 prices into our equation and use the year 2001 quantities. So this means that the real GDP for the year 2001 is $10 times 15 units of food, or 150, plus $20 times 15 units of clothing, or 300. 300 plus 150 gives us a real gross domestic product of $450. Now, to find the GDP deflator, take the nominal GDP and divide by the real GDP, and this should give us then, after we multiply by 100, some notion of, on average, how much prices have risen between the year 2000 and the year 2001. And the answer is 122. So 122 is the GDP deflator for the year 2001. To calculate the inflation rate now, we have to see how the GDP deflator has changed between the 2 years. So we now want to do a percentage change calculation. So let's do that. 122 is the GDP deflator for the year 2001. What's the year 2000 GDP deflator? Well, it's the base year. So in the base year, the GDP deflator is always going to be 100% because you're comparing that year with itself. So subtract 100 from 122 and divide by 100, and that's going to give us an inflation rate of 22%. So using the GDP deflator method, we get an inflation rate of 22%. Now, why the difference? The difference is because the Consumer Price Index looks at the change in the cost of a particular bundle of goods and services. That is, it uses the current production at the new prices. The GDP deflator, on the other hand, uses the new production at the old prices. And because you're using a different method to calculate the two indexes, it shouldn't be surprising that we wind up with different numbers for the rate of inflation. Now, notice here we've done a very, very, very simple example with only two particular goods, both of them being consumer goods, and with some pretty extreme changes in prices and quantity. I mean, in the U.S. economy right now, our inflation rate is much, much lower than 22% or 83%. So this is an entirely hypothetical example. The point of this hypothetical example is to show you that you get a different inflation rate when you are holding prices constant and changing quantities than when you're holding quantities constant and changing prices. The method of the CPI gives you a different inflation rate than the method of the GDP deflator. Now, typically, these methods will yield numbers that are not so far apart. And if we look at some actual data from history, you can see that the GDP deflator method of calculating the inflation rate has given numbers that were pretty close to the CPI method for calculating the inflation rate. Some years, the CPI is going to give you a bigger inflation rate than the GDP deflator. And some years, the GDP deflator method is going to give you a higher rate of inflation. It all depends on how the base numbers, the quantities, are changing relative to the prices. Mathematically, we could go into when this number is going to be a bigger change and when this number is going to be a bigger change. But that's not as important as you're understanding the basic method of calculating the inflation rate using these two distinct methods. Both of them are trying to answer the same question. How fast are prices rising? But because they use different approaches to answering that question, they sometimes wind up with different numbers as their answer.
Another variable macroeconomists look at is the consumer price index and the cost of living. Now, we look at the consumer price index and the general level of prices because we want to be able to differentiate between real and nominal values. In order to do this, we need to be able to determine what the general level of price is at different points in time. One measure of the price level is called the consumer price index. It's a price index that measures the cost of a fixed basket of goods chosen to represent the consumption pattern of a typical consumer. So if you can imagine what a typical consumer buys and determining how much that market basket costs in any given year. As you look at changes in the costs of that market basket, keeping the market basket fixed, you look at how prices have changed. So the technical way that the CPI is calculated for a year, say year K, where K represents some year, the CPI is the cost of that market basket in year K divided by the cost of the market basket in what's called the base year. And then we multiply it times 100. Now the base year is the year that we're going to compare all prices to. So we can see that if we're calculating the CPI in the base year, we'd have the cost of the market basket in the base year divided by the cost of the market basket in the base year times 100. It would be equal to 100. The CPI in the base year is always equal to 100. If in the next year prices have gone up 10%, then the cost of the market basket in year K divided by the cost of the market basket in the base year times 100 would be 110. So the usefulness of an index is we can compare the value of that index across time very easily. And the CPI is a price index which is intended to measure the cost of how much a typical consumer has to pay in order to live. Now, what goes into that basket? The CPI market basket includes food and beverages, apparel, non-durables, durables, rent, household services, transportation, medical, and other services. And you can see the distribution of those goods and how much is in the market basket by the size of the pie shapes in this pie graph. There are many issues related to how we measure prices in this way, but the CPI is a very good measure of the cost of living. And when we look at inflation, we're going to look at the percentage change in the consumer price index as one way to measure the inflation rate. Now, some of the issues that are related to measuring inflation in this way include no changes in the market basket over time. And so even when people change their behavior, they don't see a change in the market basket. And it doesn't account for changes in technology. But this is one very good way of measuring inflation, although we should be cognizant of those shortcomings. Now let's talk about the unemployment rate and examining the unemployment rate, how it's measured, how it might differ across countries and among different people. First, what does unemployment mean? Who is the unemployed? Unemployed are individuals who do not currently have a job but are actively looking for work. The actively looking part is critical. Someone who does not want a job and is not actively looking for work is not counted as unemployed. So it's only those individuals who actively are looking for work and who do not currently have a job that count as unemployed. How do we measure this? Well, we've got lots of different variables that we look at here. We've got people who are employed, which are people that have jobs. People who are unemployed, which are those that are actively looking for a job but aren't working right now. Those are counted as unemployed. If we add those two together, employed plus unemployed, we get the labor force. It's the total number of workers, whether they're actually working or not. The unemployment rate is the percentage of the labor force that does not have a job. So the unemployment rate is equal to the number of unemployed people divided by the labor force times 100. That gets us the unemployment rate. Another variable we look at is what's called the labor force participation rate. This tells us of the population 16 years and older, how many of those are members of the labor force. So we can look at the total labor force, divide that by population 16 years and over, multiply that times 100, and we get what's called the labor force participation rate. Now this varies over time. It varies for two reasons. One, our population changes, but it also varies because some people enter and exit the labor force. Even as you go through life, sometimes you're working, sometimes you're unemployed, sometimes you just might not be a part of the labor force. Now, how do we add all this up? Well, let's look at data from March of 2012. The total civilian population was over 242 million. There was about 88 million people that were not part of the labor force. They were either retired, they chose not to work, or for whatever reason, were not part of the labor force. Then we had those that were employed, 142 million, plus those that were unemployed. Again, those that don't have a job but are actively looking for work. That was about 12.5 million. That added up to 154.7 million people. So we can calculate the unemployment rate, which would be the number of unemployed divided by the labor force, gets us an unemployment rate in March of 2012 of 8.2%. If you look for the labor force participation rate, it's the labor force divided by the civilian population, and that would be about 64%. Now, is it the same everywhere? No, it's not. The unemployment rate changes within a country, but it also differs across countries at any point in time. Let's look at this unemployment rate across countries from The Economist in 2012. In the United States, it was 8.3%. Belgium, Sweden, Italy, France, right around the same number, between 7 and 10%. Spain, however, had a very high unemployment rate of 23%. And if we look at the low end, we had Australia, had unemployment of only 4.2%. So even at the same point in time, different countries had different unemployment rates. What else might we learn about the data if we look at it? Well, let's look at labor force participation by women. In 1948, the labor force participation rate for women 20 years and over was only 32%. By 1970, it had grown to 43%. By 1997, it had reached 60%. This trend reflected changes in our economy and society as women dramatically increased their presence in the workforce. Now, since 1997, it's remained virtually constant at 60%. What else do we look at? Well, not everybody is classically unemployed. We might look at alternative measures of unemployment and see why they're important. We could look at people that are called discouraged workers. Discouraged workers are those that have left the labor force because they could not find a job. So if you are somebody who is unemployed and actively looking for work, but you get discouraged, you might leave the labor force and stop actively looking. You're now no longer counted as unemployed. This is called discouraged workers. So if we look in March of 2012, the estimate of the number of discouraged workers were about 0.86 million. or 860,000. That's on top of the officially unemployed workers of 12.6 million. There are other marginally attached workers of about 1.5 million, and we had workers that were employed part-time that might prefer to be working full-time. That's 7.6 million. So we can easily measure, or straightforwardly measure, the officially unemployed workers. It's much harder to figure out the number of discouraged workers, marginally attached workers, and those working part-time for economic reasons. But these workers are also not really fully employed the way they would like to be, but this makes it very difficult to measure. So our measured unemployment rate are these officially unemployed workers, but we don't want to forget that there might be others that are either marginally attached or not working full-time or have just left the labor force because they've become discouraged. And finally, even at one point in time in one country, we have different unemployment rates among different segments of our population. And if we have a total unemployment rate of 8.2%, and we look at males 20 years and older, they were 7.6%. Females 20 years and over, 7.4%. If we look at teenagers, though, 16 to 19-year-olds, both genders, 25%. If we look at African American teenagers, 40.5%. So we can see that we have wide-ranging differences among experiences of different segments of our population when we look at the unemployment rate. Now that we understand how unemployment is measured, let's talk about different types of unemployment. We have three main types of unemployment: cyclical, frictional, and structural. Now these are based on the reasons that a person might become unemployed. Let's look at them in turn. Cyclical unemployment is unemployment that occurs during fluctuations in real GDP, or as the economy goes through the business cycle. If we go into a recession, people become cyclically unemployed. Unemployment rises. As we go through an expansion, unemployment goes down, and so cyclical unemployment falls. This is unemployment that is only happening because we have the business cycle. And macroeconomists try very hard to dampen the fluctuations in the business cycle and get rid of cyclical unemployment. Frictional unemployment is unemployment that occurs with the normal workings of the economy. It takes time to find the right job for a person, and it takes time for a company to find the right worker. So since the search process in the labor market takes some time, people are frictionally unemployed. This unemployment is not necessarily bad, it is just unemployment that exists as our labor market is trying to clear. Structural unemployment is unemployment that occurs when there is a mismatch of jobs and skills. This happens as the economy changes its structure, either due to demand patterns or technology changes. The demand for labor in certain markets fluctuates and people become structurally unemployed. Again, this is a sign of a dynamic economy, and although it's very painful for those that become unemployed, we try to minimize that pain with unemployment insurance and job retraining and information flow to try to minimize how much structural unemployment there is. But in the end, we think frictional unemployment and structural unemployment are signs of a dynamic, growing economy. Cyclical unemployment, we think, is only due to the business cycle, and we would like to get rid of that. So when we look at a well-functioning economy, we would expect to have some frictional unemployment and some structural unemployment. In fact, we define something called the natural rate of unemployment. This is the level of unemployment at which there's no cyclical unemployment. It consists of only frictional and structural unemployment. This is our target unemployment rate as macroeconomic policymakers. If the unemployment rate is equal to the natural rate of unemployment, then we are at what's called full employment. It's the level of unemployment that occurs when the unemployment rate is at the natural rate. Once we've been able to get a measure of the price level, and we can do this in various ways, as we just talked about, we can do it by looking at the consumer price index, we can get a measure of the inflation rate. The inflation rate is the percent rate of change of a price index. So if we look at the price index over time, we can see that prices have generally risen. Here's a price index for U.S. GDP from 1875 to 2012, and we can see relatively flat, and then prices rising from 1950 on. It was rising back here also, but given the scale of the graph, we can see dramatic increases through the 1970s. And that's some comparisons. If we look at postage stamps, in 1940, a postage stamp cost 3 cents. 2012, 45 cents. Those increases in prices, along with increases in prices of other goods and services, are reflected in increases in this price index. Let's look at some more comparisons. The price of gasoline in 1940, 18 cents. 2012, $3.65. A house, $350,000 in 2012, $6,500 in 1940. A movie ticket was only 25 cents in 1940, $12 in 2012. So you can look at the various different prices in 1940s, compare them to 2012, and you can see that the CPI or any price index will have risen over that time period. If we look at the percent change year after year, we get a measure of the inflation rate. This is from 1950 to 2010, and you can see that inflation was relatively volatile through the 1950s, rose gradually through the 1960s, and then in the 1970s we get to a period called the Great Inflation, where prices rose dramatically. Inflation went up to around 10% and averaged 6.8% from 1970 to 1980. Beginning soon after 1980, we see a reduction in inflation, and average inflation from 1990 to 2011 was only 2.2%. Now, there are significant costs to unemployment, both to the economy and to individuals that are unemployed. The cost of cyclical unemployment to the economy is lost production that can never be regained. However, there are significant and severe costs to individuals that become unemployed. There's loss of income, there's loss of social status, there's all sorts of costs to an individual. We as a society try to mitigate those costs with unemployment insurance. Those are payments unemployed people receive from the government. This differs across different societies and different countries. But at some level, there is some level of unemployment insurance in many economies. Other costs that are associated with unemployment are the loss of skills and the difficulty in finding another job. We know that studies show that the longer somebody is unemployed, the harder it is for them to find the next job. So oftentimes we look at the duration of unemployment, how long somebody's been unemployed. In March of 2012, 42% of the unemployed individuals had been unemployed 27 weeks or longer, and only 20% had been unemployed fewer than 5 weeks.